guys, what if I told you that you could build something with Golang that would enable you to crawl through the sitemaps of any website over the internet, and also help you get some SEO rated data in terms of the quality of SEO that they've implemented, right? That'll be interesting, right? So in this video, we're building a sitemap crawler that helps you with SEO. And what we're going to do is we're going to give the XML sitemap file, the link of the file, to our program. The program will go through all the links in the sitemap and also going to visit each link, which is basically crawling through each of the link to make sure that all the pages belong to the website, and that's how the pages are meant to be crawled. This is exactly what the Google crawler does. It goes to all the website and it uses the sitemap to crawl through all the pages, right? And the better your sitemap is, the easier the job of Google crawler is, and then the better SEO score that you get, right? So now this video is going to be very interesting. This is a video series, by the way. This is the part 1. We're going to have subsequent videos coming up. If you want to stay updated, you have to press the subscribe button, and that will update you whenever the new video comes up in this series. It's not going to be a long series. There'll be probably 3 or 4 videos max in this video series. So here's what we're going to do in detail, right? Now I take everything to the drawboard first, right, before I write any even a single line of code. And that's because if you don't do this, you're going to make a lot of mistakes. So when you start out in your career as a developer, the first 3 to 4 years, you probably won't approach problems like this, right? But once you have a lot of experience under your belt, like let's say 7-8 years, you would know the importance of planning something out on a drawboard before you attempt to write the code. And if you're a junior developer, you can start doing this from today, and this will save you years of your years of maturity. Basically, you will mature mature to tomorrow itself, and you'll be working the way senior developers work, right? I'm not even talking about senior developers, I'm talking about architects. This is how architects work, right? Who architect the whole program. So basically what we're doing here is we're architecting the entire flow of the program, all right? So I'll take you through each of these steps. So, and once you have understood these steps, and once we start programming and writing the code, everything will make a lot more sense to you, and everything will be very, very easy to understand because you've already seen how we're going to approach the problem, right? What we want to do is we'll first create a struct called SEO data, which basically we're telling Golang, this is the struct and this is how we're expecting the data to be. So it will contain the URL, the title, H1 tag, and meta description. Meta description being the most important tag in for SEO on a page. I'm sure you know that already. What we're going to do is we're going to create user agents. So when we request something from a website, the website knows that it's a Chrome browser requesting something, but if it's but you have to define user agents so that our crawler Golang can also go and represent itself as a browser like a Mozilla or Firefox or whatever, right? So and then you have a function to pick a random user agent, right? So we don't for each request we want to pick a random user agent, all right, so that it looks like the requests are coming from multiple sources. And then you have, so this is the best practice. Basically this is the best practice to approach crawling with. Otherwise you if there's a lot of requests from you, then you might end up getting blocked. Then what we'll do is we'll have our main function. We'll define an XML file in that main function, which will be the sitemap. So the sitemaps are always .xml files, right? So you need to get the link of that. And in this video tutorial, we'll use an already existing sitemap from another website, which is more like a testing sitemap link that we'll use, but you can substitute that with any other link that you want, all right? And then we'll send it to the crawling function. So we'll have another function called crawling function. On the left, what I've done is I've written out all the reusable functions that I may have in this complete program. Why reusable functions? Because what happens is when you start coding, you kind of lose track of the number of functions that you require. So you might end up writing a lot of repetitive code, and I don't want to do that. So as an experienced developer, you always want to note down the kind of functions that you'll be creating, so that you can determine what are the functions that you can reuse again and again. If you're performing any operations again and again, you can reuse those functions, right? So I'm training you to think like an architect and a senior developer. So then what you're going to do is you're going to send a GET request to this page and get a response, right? So which is basically the sitemap page. So we send a GET request to this page and get a response, and then we check if the response received is in fact a sitemap. So to make requests, I'm going to create a function called make request function, which will help me to always make requests. And then this is going to be done by is sitemap function. to check if in fact the XML file is a sitemap, right? If somebody puts a bogus link, I don't want to consider that as a sitemap and put my effort in actually trying to get data from it, right? And then what I'm going to do is I'm going to go through the sitemap. I'm going to extract all the URLs on that page, because that's how crawlers work. They extract all the URLs on the page and then they start visiting those URLs. That's how they know how to actually go through the entire website, right? It's a sitemap. So and then what you're going to do is, so this will have an extract URL function which will help me extract all the URLs from the page, and then we have to make a request to all of these different pages. So I'm assuming we'll have routines here, right? So we're going to use routines, and then what we'll do is we'll make a request to all these pages one by like simultaneously, all the different pages, and get their responses in HTML. So again, we'll use the make request function. So now you understand why I do this reusable function planning, because now I can use the same function here, because I know that I'll be making multiple requests. And then we'll have our crawl function, where all the pages that we get as a response HTML, we're going to crawl through all of those pages, and then we can convert it into usable SEO data. So I'm going to this is another function called get SEO data function, where I'll convert the data that I get into the usable SEO data function, which will be in this format, in the struct format. All the other data that I don't want to use, I will completely ignore. But if you want to gather any more data, like let's say all tags and all of that stuff, you can do that as well. You can make changes to the struct. You can make changes here in this function, and you can extract as much SEO data as you want from a page. So it's going to be completely customizable, right? The whole program is going to be completely customizable. You can reuse this code, do whatever you want with it. You can make changes. All right. So I hope this makes sense. Do subscribe to this channel. If you're new to this channel, then I want to tell you that we have more than 100 videos of Golang on our channel. So if you're learning Golang right now, take a look around and do subscribe so that you can learn. And we have almost a new video coming out every day. So this video is the second video of the series, which is for crawling a sitemap. So you can crawl using the code that I'll show you in this series. You'll be able to crawl the sitemap of any website on the internet. So in the first video, I've shown you the approach that we'll be following. And right now in this video is when we'll start writing the actual code. So let me take my terminal. I'll just increase the font so that you can see everything. And what we'll do is we'll create a directory called sitemap, or let's say YouTube sitemap crawler. All right, and we'll cd into it, and here we'll initialize this program. So we'll say go mod init github.com/akhil/sitemap crawler. So whenever you start a Golang project, you have to initialize it saying go mod init, which creates a mod file for you, go.mod file. And if you're from a JavaScript background, this is like npm init. So it creates a go.mod file, which is like package.json, which basically creates the list, keeps the list of the dependencies that you'll be using in your project. So let's do that. So it says it has created a new go.mod file for us, and as in when we'll keep installing new packages in our project, it will create a go.sum file, which is the equivalent of package.log.json file if you're from a JavaScript background, which basically has the list of the dependencies that you're using in your project. All right, and what we'll do now is we'll open up our code editor. So in this case, I'm using Visual Code Studio. Sorry, not Studio. I think it's just Visual Studio Code. Sorry, yeah. So I'm using VS Code, and you could be using anything else. It doesn't matter. So this video, we're going to just create the outline of our project, which we'll just write the outline of the functions, and in the next video onwards, we'll start creating the actual functions. This won't be a very long series, maybe just 5 to 6 videos, 10 minutes each, and we'll be able to complete the entire project in that. So let's create our file main.go. If you haven't seen the first video of this series, then I strongly suggest you go check it out. I'll leave the link in the description below. So the first video of this series, you'll be able to understand what we're going to do with the diagram, and then in this video we'll start writing the code. So if again, if you're new to this channel, then if this is your first series, then I would say that you can I'll recommend 2 other series to you. One is the Bing Scraper. There's a series on Bing Scrapers. You can go to playlists and check it out, and there's a series on Google Scraper. So it's best if you check those out before you watch this series, because we're going to build on the concepts that we have learned in those series. We're going to use them here. So even if you've not understood the concepts there, I'll still go through everything line by line here. So it's not that you have to watch them, but if you watch them, it'll just give you a more solid understanding of what's happening here. But I'll still go through every single line. I'll explain to you everything what's happening here. All right. So the first thing that you usually do in your main.go file is the most important file in your Golang project. So main.go file, the first thing that you do is you write package main, and then you say import, and the import statement will basically have the list of all the packages that we'll be using. Some of them could be not third party packages, and some could be third party packages. All right, so we'll import them here based on whatever we need in the project. Then we'll have our func main, which is like your entry point into the project. So this is your most important function, right? And from func main, I'll be calling a function called scrape sitemap. So this is going to be our most important function. Okay. And the most important function, because this is going to do the majority of the work for us. So the data that we want after scraping the sitemap, we want also the SEO data. So if you watch the first video, you understand that not only are we going to scroll through the sitemap, but we're also going to assess SEO data from the site. So we'll create a struct. So structs are basically your own data types in Golang, where you can store data in a particular format. So we're going to create our own struct called SEO data. So I'll just write SEO data for now, and it's going to be a struct. All right. And then we'll have to also parse a lot of information from the pages that we scrape or crawl. And then that means we need a parser, which will be of type interface, and we'll get into that later on. So if you have not read about interfaces, not a problem. We won't get it too deep into it, but you can go and check other videos on interfaces. So it's an easy concept, it's not very difficult. And then when we have our scrape sitemap function, so let's actually create that functions func scrape sitemap function. Okay, so it's going to obviously take a couple of parameters. It's going to return something, so we'll talk about that. And the scrape sitemap function is going to call a function called extract sitemap URLs. This is the function it's going to call. All right, and it's also going to call another function called scrape URLs. And this extract sitemap URL function is going to call a function called. So first, let's write down the outline of this function. It will be extract sitemap URLs function, and it's going to call a function called make request. So the make request function is pretty clear. It's basically going to make a request, like a get request to the link, so that we get the data, and then we'll take that data. We'll use an external package called I think it's called GoScrape. No, it's called GoQuery. Yeah, sorry, it's called GoQuery. So we'll use the package to get whatever response we get from the request, and then we'll convert it into an object that's readable by Golang. Okay, so that's what our make request function does. And then we'll have a function called scrape page function. So we'll have, but before that, I think I'll just write down these functions. So we'll have make request function. It'll take some parameters and will return something, and then we'll have our scrape URLs function. So we'll have func scrape URLs, and then we'll have our scrape page function. So we'll say func scrape page, right? And then we'll now to scrape a page. Before scraping a page, we'll have to crawl it. So we'll have a crawl page function as well. So we'll say func crawl page. So right now I'm just over the top of mind, I'm just writing down the approach based on the diagram that I showed you in the first video. I'm just writing down the approach and creating like a skeletal map of the functions that I want to create. But what type of data types they'll accept, what they will return, and the actual definition of the functions, that we'll have to think through together, and we'll create everything together. So we'll have, so this is, by the way, a really good practice. So first you draw the diagram like I did in the first video. That helps you plan the entire project, and then once you write down these functions in skeletal format, that helps you basically understand the flow of how you're going to proceed. All right. So then I'll have a function for get SEO data. So I'll have func get SEO data function. So these are all the functions I'll have. I'll have a main function, I'll have a scrape sitemap function, which will basically call the extract sitemap URLs. So it will go to a sitemap, it'll extract all the sitemap URLs, it'll scrape those URLs, and it'll make requests. It'll scrape the pages. To scrape the pages, you have to crawl the pages, and then you'll parse and get the SEO data, right? So all of these things it'll do. So that's how we'll build a sitemap crawler, and which also gives us SEO information. And we'll have a struct for our SEO data. That's the most important thing. And then we'll have a parse interface, and then to make requests we'll be using user agents, and then we'll have a function for selecting a random user agent. Now the reason why I said that that I recommend watching the Bing Scraper and the Google Scraper series is because of user agents. So I've explained what user agents are and how they work, and if you have not watched those video series, then I'll explain to you here again. So a user agent is basically like a browser telling the website, any website, that hey, it's not like a bot scraping your website, it's like a human being. So it's like a human being signature kind of a thing, like an actual how a human being would use a browser to visit a website. That's how we'll make the request. So that's why we need a random user agent, and we'll need that in our make request page. So we'll need this random user agent there, and we'll have a list of user agents. And then we'll use our random user agent function to select a user agent from this list randomly, and then use that to make a request. So every single request, every time we make a request, we'll use a separate user agent, so that we don't end up overloading the website, or they don't end up blacklisting us. All right. So this is the outline of the function of the entire project. In this video, we'll start writing the actual functions. So in the first video, we saw the diagram on how we're going to approach the entire project. The second video, we started writing these skeletal functions. And right now, let's start working with our main function. So which is the first function where the program will enter. So here, what we'll say is we'll create a variable called p, and we'll say it's a default parser. Now default parser is basically a struct again. So we'll go here, we'll say type default parser, and we'll say struct. And here while we're at it, let's complete this as well. So we'll say type parser interface. Okay, and let's complete the SEO data struct as well. So we'll say type SEO data struct. And so the things that we need from so we'll get an unstructured data, we'll get some unstructured data, and then we want to extract the useful information from it. So that, which is what our parsing function will do. So the parsing function will take this unstructured data and create a struct out of that for us, and the struct will have user defined, or defined by us on some values that we need to extract from that unstructured data. All right. So we'll the URL is what we want from that data. Then we want title, we want the h1 tag, we want the meta description, and this is all the description, and this is the SEO data that we need. And we also need a status code, which will be like 200 or 404 or something like that. So it'll be int basically, and this will be a string. H1 tag again is a string, and the title is a string, and the URL is definitely a string. All right, so this is your SEO data struct. Now let's go back to our main function. In our main function, we'll call this function scrape sitemap. I'll keep the S capital and I'll make the M small, so it's scrape sitemap. And here we'll enter the URL that we want to scrape. So let's think about it later on. Let's think about the website that we want to scrape. But not only the website, but we'll have to find out the sitemap link for that website, and then we'll send that sitemap link into this scrape sitemap function. All right. And let's take that value that we get in a variable called results. And we'll range over those results. So we'll say for, and for the iterator, we'll put a blank character, and every single value that we get from the results, we'll take it into this variable called res, and then we'll range over the results. And then we'll say fmt.println and res. All right, so we're just going to print out all the results that we're getting. That's simply it. So now let's start working on this scrape sitemap function. So the scrape sitemap function, we'll obviously get a URL, right? The URL that we need to scrape. So we'll say URL here, and it's going to return a slice of type SEO data. Now SEO data, as you know, is our own struct. It's our own data type, which has these 5 different values, and that's what and a collection or a slice of those different results is what we're going to return from this function. Now we'll call this function called extract sitemap URLs. I'll make the M smaller, and here we'll pass this URL that we get into this function. All right, and we'll take that into a variable called results, and we'll like I said, we'll call this function called scrape URLs. Here what we'll do is we'll just pass the results that we get from this function, extract sitemap URLs. The results that we get, we are passing that into the scrape URLs function. Okay, and we'll take that value in this variable called res. And res is basically the structured data that will come back from this function, and that will be in the format that's acceptable to us. That's based on our struct of SEO data that we have defined. So the res is the most important thing, and that's what we're going to return from this function, right? So res is basically going to be a slice of type SEO data, where SEO data is the struct that we've already defined. All right. So that's what the scrape sitemap URL function does. Now let's also talk about the extract sitemap URLs function. So the extract sitemap URLs function, it takes a URL. So let's call it the start URL. That's string, and it returns a slice of strings. So the extract sitemap URLs functions takes the URL that we receive in this function, and then it returns this results, where results is basically a slice of strings. All right, and here I'll make a channel. I'll call it the Worklist channel. So we'll say make chan string channel, and I'll create a function called toCrawl, which will be a slice of string, and right now it's empty. And here we'll start a go routine. So we'll say go func in our Worklist. We'll give it a string and start URL. Now this Worklist logic, the whole logic of creating a channel and publishing all the links that have to be crawled to the Worklist. So this logic has been defined by me, explained by me in this video called the Guardian scraper, the Guardian.com scraper. So you can go and check it out, and in that you'll understand this complete theory properly, because I've drawn diagrams and I've shown you properly on how this Worklist channel works. So we're basically using it to publish our the links to be scraped, basically. So that's why we're using this channel. And here to start off this routine, we'll put these round brackets here, and we'll start off a for loop. We'll create a variable n. I'll talk about that later. Okay, but for now, let's not work on this for loop. Let's work on the let's take our work list. All right, and for the work list, by the way, the W is capital. So we'll take our work list and we'll take all these values in a variable called list. Okay, and now we'll have to range over the list of all the URLs. So we'll say for blank character link range over the list. And when you range over the list, you start another go routine which takes each link one by one, and it makes a request. So we'll say make request, which we've already written here, right? So we'll just take this, cut this and put it here. So the work list is a channel where we are publishing all the links to be scraped. We are taking all that, the complete work list that we have. We'll put it into a variable called list. We'll range over that list, and then we'll run a go routine to make requests. Now we're using go routines because we want to make requests simultaneously. All right, we don't want to just make requests one by one and sequentially. We want to make it to a concurrency there. So we'll make a request to that link, and then if so, before this, I think we'll have to accept that in a variable called response and also error. And so if error is not equal to nil, we'll say log dot printf error retrieving URL %s comma link. All right, and we'll call a function called extract URLs here. The response that we get here, we'll send it to a function called extract URLs, and we'll take that value in URLs. So if things are not making sense right now, don't worry, I'll go through it again like properly. But if you watch the Bing.com scraper and the Google scraper and the Guardian scraper, you will understand everything about these random user agents and how we make requests and all these channels. Everything will make a lot more sense to you. But even if you don't understand it, if you've not watched those videos, you don't understand this, don't worry, I'll again explain to you the whole process again, and everything will make sense to you. All right. And here again we'll say if error not equal to nil, we'll say log dot printf error extracting document from response %s, and we'll type out the link. Okay. And then we have another function called is sitemap. I'll get into why we need that function, but for now just bear with me. So this takes the URLs that we got from extract URLs function, and here we'll say sitemap files comma pages. If sitemap files not equal to nil, sitemap files. Don't worry about this right now, I'll explain to you. And here we'll say we'll range over all those pages that we've just received, and we'll put it in a variable called toCrawl, and toCrawl will append that page. Okay, Okay, and here we'll say link. Okay, and from this function we'll return to crawl. All right. So all this function that this function is doing, extract sitemap URLs, is returning a list of is basically returning a slice, which you can call it as a list basically. So it's a slice of URLs to crawl, right? That's what extract sitemap URLs is sending to results. All right. So it takes a URL, it goes through that, it goes through those URLs, and then it creates a complete slice of all the URLs that need to be scraped, that it finds. So now let me first complete this for loop here. So this for loop starts off like this, and it has a in this for loop we're doing this, that, right? We're taking that into the work list into the list. But here, after the for loop here, we're also incrementing our n by value, and we're keeping a variable called n here, which is int, and we're incrementing n again by n++. Now in the video for the Guardian scraper, I've explained this entire process where we take this variable called n and how it creates a loop, a never-ending loop to discover more and more and more URLs and keep adding that to our worklist channel, and how that keeps us in a loop to keep getting all these links, keep discovering links till it has completed the entire page, right? So I've explained that properly in that video along with diagrams. So if possible for you, you should go check it out. If you've already seen it, then this will make complete sense to you. If you've not seen it, then I'll try and explain it to you without drawing diagrams in that video. But what's happening is that I'm running out of time in this video, and I know that this function you've probably not understood properly. There's a lot happening here, but I'll try to explain to you in the next video, and I'll also carry on the rest of the functions in that next video. So do stay subscribed to the channel, and thanks a lot for watching. This is the 4th video of the sitemap crawler series, and in the first video we saw the entire approach using a diagram on how we'll approach the project. Second video we started creating the outline of all the functions. The third video we created a struct called SEO data, and extract sitemap URLs function, scrape sitemap function, and the func main. And in this video we'll start with our user agents, and we'll create the function for random user agent. Then we'll also work on our make request function and our scrape page function. And so let's get started. Let's work with them on the way. So for our before I do all of that, sorry, I'll work on the import package. So here we'll have fmt, we'll have log, we'll have net/http. fmt if I want to print out stuff, which I do. Log if I want to log out errors. Net/http to make requests. And I want to work with strings, so I'll use the strings package. And since we'll be using math.random function for selecting a random user agent, so I'll use math/random. I'll use time, and I'll also use github.com/puerquito/bio/goquery. So in case you don't know what goquery does, it basically takes a response, like let's say you make a request to a page, you get a response, it converts the response into a readable document that Golang can read. And I have a series, a video series of two videos on my channel. It's called building a simple scraper using goquery. Goquery is a very famous popular library, you can go check it out. So goquery is the one that we'll be using here. I use it very, very often, and it's a very, very simple to use library, so that's why I use it. And so let's get back to our user agents. All right, so in our user agents, it's going to be a variable, and it's going to be a slice of strings. So what I'll do is I'll copy and paste a sample user agent for you right now here. I'll put a comma after that. So this is a sample user agent. So this helps us our server look like a browser when making a request to any website. All right, and like this we'll have 6 to 7 different user agents. I'll push this code on GitHub, and you can just copy and paste all the user agents, but for now I'm just putting one just to show you as a sample what they're going to look like. And then we have a function for random user agent selection. Okay, so it basically returns a string. So it's going to go through all these user agents and going to return select a random user agent, and it's going to return a string. Okay, so we'll say ran.seed time.now .unix. Sorry, this bracket doesn't end here, it ends here. And we'll take a random number, we'll say ran.integer percentage length of user agents. In short, what we're doing is we are just taking the random library, math/random library, and we're creating an int basically, and we're dividing it by the length of the user agents. So let's say if there are 5 or 6, so we'll divide by length, and it basically helps us select one of these basically. So if you say return user agents, so since you get a random number, and that random number is somewhere between the length of these user agents, so like let's say if these are 6 user agents, so 1 to 6 will be the value that you'll get. And so when you return something from user agents and you say that it's at the index of random number, so random number basically so it'll be like 0 1 2 3 4 5, it can pick up any value from there and then send back to you, right? So that's how basically selecting a random user agent works. Anyhow, now what we want to do is we want to work on our so last time we made this function, right? It was called Sitemap. Yeah, we talked about Sitemap. So let's build this function, right? Sitemap. All this function does is just checks if a particular page is sitemap. So how do you come to know if a particular page is sitemap? It basically needs to have a .xml format. So that's all we'll do, right? So we'll say func is sitemap. It takes URLs in the format of slice of strings. It returns a slice of strings, 2 slices of strings it returns. Okay, and we'll say sitemap files is a variable which will be equal to slice of strings, and it'll be empty for now. Take a variable called pages, which will again be an empty slice of strings. And here what we'll do is we'll range over the URLs that we have received. So all the URLs that we receive in our sitemap function, you can see, we'll range over them. So we'll say range URLs, and for ranging we'll have to use for, and for the iterator I'll use a blank character, and here I'll use page is equal to range URLs, and we'll take a variable called found sitemap equal to true. So it's fmt dot println sitemap comma page. It says sitemap files is equal to append sitemap files comma page. So we took the sitemap files slice and what we're doing is whenever we find a sitemap, we append it to our sitemap files slice. Basically that's what we're doing, right? And but else if it's not true, then we'll append it to pages. So we'll say append pages, page. And all we'll do is we'll return sitemap files from here, pages. All right. So that's what we get here. So we get sitemap files and we get pages here, right? So in the last video, if things were not making a lot of sense to you, I'm sure everything starts making sense to you now. And as and when we'll keep creating all of these different functions, like for example, now when we'll create make request function, the rest of the part will make more sense to you, and so on. All right. So now actually let's do that. So let's work on our make request function. But before make request, I think we should work on the scrape page function. So if you remember in the last video, we talked about scrape page function. So to scrape a page, you need to be able to crawl a page, and then we'll get SEO data from that page. Okay, so let's just create a simple function here. It takes a URL which is string, and it takes other things. Let's not talk about those, it'll confuse you. And it returns some things. The scrape page function returns some things. So one thing that it returns is an SEO data and error, right? So the SEO data that we want, it will return from here. And so what this function does is it calls another function called crawl page, and which returns a response and an error. So if error not equal to nil, we'll return SEO data. I'll keep S capital just to be consistent everywhere. Error. And here we'll say here what we'll also do is we'll pass the parser interface. So we'll say parser of type parser. It's an interface, and here we'll say parser dot get SEO data. Error not equal to nil, return SEO data, error, otherwise return the data nil. So if there is an error, which means error not equal to nil, we'll return an empty slice of strings called SEO data, or otherwise and also the error. Otherwise we'll just return data and nil for the error. All right. So what we'll do now is we'll actually work on our function make request. All right. So in our extract sitemap URLs function, we were calling this function called make request. Let's work on that. Let's work on the make request function. So all this function does is it just makes requests to the pages, right? So we'll say URL string and http dot response error, and here we'll say http dot client. So to make requests we need a HTTP client, which that's why we're using the HTTP package, as you can see here up here. And here we'll take a timeout of 10 into time.second. We want to delay between our requests so that we don't end up overloading the website, and this is why we're using the time package that we get from here, the time package. Okay, so the client that you get from here, we'll take it in a variable called client, so that becomes easy for us to access this client. And now we'll use the HTTP package again to make a request. So we'll say new request. The type of request that this function will make will be get requests. and here we'll say request error. All right, and let's set the header for a request. So when sending a request, in the header we can set who this request is coming from. So we're setting the random user agent using the random user agent function that we have just created. And if we get an error here, we can capture that. So we'll say if error not equal to nil, that means if error not equal to nil means that if there is an error, then it returns nil here, and it just returns the error. That's all it does. If all is okay, then we'll just make a request. So we'll say client.do, and in the brackets we'll say request, and whatever response we get, we're going to capture in the variable called response. If there is an error, so if error not equal to nil, we'll return nil and error. But if everything went all right, we'll just return the response and nil for the error. So this is what our make request function is all about. And I'm sure it's if you were having issues understanding a lot of things in the last video, I'm sure that everything makes a lot more sense to you right now, and this entire function is now much clearer, because I've shown you the sitemap function, I've shown you the make request function, and you understood why this is getting appended here. All of this makes a lot more sense, I hope. And as in when we keep building more functions, things will start making more sense to you. So since we've gone a little over time, what I'll do is I'll continue this in the next video. We had reached quite far in our fourth video, and so I was thinking of handling my sitemap logic, the XML logic, in another for loop, but I think I'll just it's simpler to just handle it out here. So what we'll do is we'll say found sitemap is equal to strings dot contains page slash XML. So here itself we'll check if our page contains XML. If true, then we'll proceed, and then we'll say found sitemap and the rest of the logic. All right. So all of that is complete, and now what we'll do is if you've seen that we said parser.get SEO data function, because we'll be using our interface here. So we'll say get SEO data response http dot response SEO data header. All right. So this is what it takes, and this is what it returns. Now let's start working on our get SEO data function. All right. So here we'll say let's find where we had written our SEO data function out here. Yeah. Here what we'll do is we'll say D is default parser, and it takes response http dot response and returns SEO data, error. The first thing that we'll take is we'll take the response and we'll send it to our GoQuery library, and we'll use a function called new document from response. So this is a function that we've used very commonly in all the other videos as well. If you've seen the Google Scraper series, the Bing Scraper series, and even the GoQuery Scraper series, so we use this function very commonly. So we use GoQuery dot new document from response, and we send the response here. And take these values in a doc, or we get an error. So if there's an error, that means error not equal to nil, you'll return SEO data but empty, and you'll return the error as well. So what we'll do is we'll take a variable called result, we'll make it of type SEO data. So SEO data is our own struct that we have created out here. So that's what we're taking. And here we'll say result dot URL equal to response dot request dot URL dot string, and result dot status code response dot status code, and we'll say result dot title not done. So once you send your response to the new document from response function of GoQuery, you get this doc, and on this doc you can start running functions like find. So this basically makes it operational. Basically Golang can run operations on this document, so that's why we run this function. And this doc, we'll run a function called find on it, which will basically find all values with title okay, and we can also find h1. We'll say doc1 dot find h1 dot first dot text, and here we'll say result dot meta description doc dot find. So all we're doing basically is finding out the meta description. So if you know basic HTML, you know that we have meta descriptions, right? So that's all we need to find for the SEO data, and you can feel free to extend it further. I'm going to keep it only till meta descriptions, but you can go with all tags and all of those different things if you wanted to. Let's say content, and here we'll say return result comma nil. Okay, so this is our get SEO data function. Now what we'll do is we'll work on our extract URL function. So as you can see, that this function called extract URLs, right, in our extract sitemap URLs function, and we have not started working on that function. So what we'll do is we'll come here, we'll say func extract URLs. It takes response, which is a pointer to response, returns a slice of strings and an error, and what we'll do again here is we'll run it past our GoQuery library, and the same function we'll say new document from response, and response, we'll send the response to it. And then similarly here also we'll get a document and an error. All right, very similar to your get SEO data function. And here again what we'll do is we'll check for the error. So we'll say if error not equal to nil, return nil comma error, and we'll take a variable called results equal to a slice of strings, which will be empty for now, and we can start selecting nodes. So we'll say range select dot nodes locations equal to cell dot aq I. Actually no, let me go back and let me work on it again. So we'll say for I equal to range select dot nodes, and where do you get these cell from? You get it from here, is equal to doc.find loc, and here we'll say loc dot equal qi set result c dot text results append results comma result, and here we'll return results comma lf if everything goes well. So all that this is simply doing is it's basically extracting all the URLs from the page. So it's taking the page that you're sending to the response from the page that you're sending to it, converting into document, and just extracting all the URLs one by one, and it's appending to basically this value called results. Results is basically a slice of type string. That's all that this function is doing. All right, and this basically selecting nodes and location, all of these things, this is very common. You have already seen it. I've already explained it in my Google scraper and my Bing scraper series, so I don't think I have to go through this again. It's very straightforward. So I'll keep this video short and we'll end it here, and in the next video we'll continue from where we left off out here, and we'll continue working on our crawl page function and our scrape URLs function. I think just 2-3 functions are left, and then we're ready to start running this program. And I'm sure there will be hundreds of errors, but we'll solve them together, so don't worry. Just keep writing the code along with me. And even if you don't understand things, it's all right. Once you code along and once you run this program, you'll start understanding a lot more things. So it's very important to start doing practicals. And also, if you have any errors or any big issues, you can put that in the comments below. I'll help you sort it out. Don't worry. Now, I want to quickly repeat what we're trying to do here. We want to go to a website, and basically we'll put the sitemap URL link here of that website. So usually websites have almost all websites have a URL, especially the ones that want to compete and want to be really good at SEO, right? So they have a sitemap URL, and then that sitemap URL is what we're going to put here. So our program is going to go to the sitemap URL and is going to crawl every single link on that sitemap. So sitemap is basically a page which has all the links to your website, all the links of all the pages in your website. Our program is just going to click on every single link and is going to scrape that entire page. Okay. And just to verify, just to see that everything works. So that's why it's a sitemap crawler. So right now we're just going to scrape it. We're not going to do anything with that information, but that's where I'm going to leave this program off. But you could take this program and build and take this and do it, use this functionality for any other website that you want to crawl. And using the sitemap, you can crawl every single page of that website and actually do something that you want with the information. For example, you want to harvest other people's email IDs from, let's say, websites, or you want to get phone numbers, or you want to get some information like news information, you want to organize that. This is the way to go. You get to the sitemap, use crawl all the links, and you scrape all the pages. So we're going to crawl through the links, we're going to scrape all the pages, but we're not going to do anything with the information, right? So you'll be doing something with the information later on if you want to. Okay. So I hope that makes sense. Now, when I say doing something with the information, I mean that you can store it, you can mine it, you can refine it, you can use machine learning to train on that data. You can do a lot of stuff, and I can cover that in one of the future videos, but that's not the scope of this series. Here I'm just teaching you how to crawl and how to scrape, right? So now coming back, I want to start again from func main. And so P is something called as a default parser, right? Now default parser is an empty parser right now. It's an empty struct. And parser is an interface that helps you to talk to this function very easily, get SEO data. Okay. Now, coming back here to a func main, what I want to do is I want to actually put in the name of the website that we'll be scraping. Now, there's a very famous website when it comes to SEO. There's a very famous website called QuickSprout. It's owned by this person called Neil Patel. He's the biggest person in SEO. And his website is the one that we'll be scraping. All right, so let's put in his website. It's quicksprout.com. You can check it out, /sitemap.xml. So usually if anybody wants to do really well with SEO, your sitemap.xml needs to be right there with your domain. It can't be with your subdomain, or it can't be like, slash about slash sitemap.xml. It can't be like that. It has to be on your main domain name. So it's coexplorer.com/sitemap. So I'm assuming, since he's the guru of SEO, that definitely he would have kept a sitemap.xml like this, right? Now there are two more things that I'm passing here, P and 10, which I'll talk about really soon. Now, when you look at this function, scrape sitemap, you can see an obvious default here that I made in the long time back when I made the 5th or the 4th video. So I need to fix that. It needs to be capital S, because that's what I'm calling here, scrape sitemap. Okay, and you notice here that's only taking a URL for now, but we want to take something else also. We want to take those two other values as well. So what I want to do is I want to say it takes a parser, and parser, by the way, is the parser that we talked about, that we created here on top. That's the parser is taking, right? So parser called P, which helps us to talk to this get SEO data function later on. All right. So it takes a parser of type parser, which is an interface, and when we say 10, we are basically defining the concurrency. So that's what we're also taking. Now all this function returns is the SEO data. SEO data is the struct that we've already defined, right? So I'm just going over all of this. I know you might feel like you already know all of this, but I'm just going over it so that you don't miss out any information, because it's been quite some time since you must have done the 5th video to this 6th video now. So SEO data was that struct, and we want the data to be structured in this way, right? The URL, title, h1, meta description of all the pages that exist on our website. Now, like I said, even though we are scraping the data, we're getting it in this kind of a struct format, but we're not doing anything on the data on the pages. But you could, if you wanted to use this program, you could actually deploy this program, because it has concurrency. It's very fast. It's super efficient code that we are writing right now. You could use it to actually scrape a huge website and get all of the data, scrape the data, and structure it like this, like I showed you. I showed like 5-6 fields, but you could have many more fields. You could structure it, and you could actually do something with the data, like get phone numbers and extract email addresses and all that stuff. All right, just an idea, just a business idea that I'm giving you. By the way, I do this for my product, Dominate.ai. This is what I do. I have millions of scrapers out there on the internet, scraping millions of websites, and they're getting all this information for me, like emails and phone numbers, and that's what I kind of organize and structurize, and I provide and clean all the data, and I provide that on my product, Dominate.ai. I provide that to salespeople. They subscribe to my platform, and they get access to this kind of data. All right, so that it makes it easy for them to sell. Anyhow, so I just gave you a very awesome business idea. Anyhow, now going back. So that was our sitemap, scrape sitemap function. Now you see that in this extract sitemap URLs function, right, which basically extracts all the URLs from the sitemap, you're just passing the URL of this link. But in your scrape URLs function, you want to pass something else. You want to say, you want to pass the parser, and you want to pass the concurrency. Okay. Now that means that we have to go back to our scrape URLs function and work on it. So till now we haven't worked anything on our scrape URLs function, but this is an important function. So now you just saw that it takes URLs, sorry, not here, but within these brackets, it will take URLs, all the URLs, not URSL, but URLs, and which is basically a slice of strings. And you just saw that it takes parser, and you just saw that it takes concurrency. Now just make sure it's consistent with your other program. Now what's happening here is that you get all the URLs, right, in your variable called results in this function, scrape sitemap, and you call the scrape URLs function, and you pass all the results that you just got from this function. You pass the parser that we had here, and you pass the concurrency, which is 10. And now going back to your scrape URLs function, it has to return something, right? This function returns something. In our case, this function returns SEO data. This bracket needs to close here, the square brackets, to indicate that this is a slice of SEO data. SEO data is our own struct that we have defined out here, SEO data.
So struct is basically a collection of different data types that you can create inside Golang. So it's our own defined struct. So now let me go back to my function scrape URLs. Okay, here the way I want to start is I want to create a variable called tokens. And it's nothing but a channel with a set number of concurrency, like 10. Concurrency of 10 is a channel. Then I define a variable called n, it's an integer, and I define a worklist of different links. It's again a channel of slice strings. And because we want the SEO data to be structured, we want to return a structured data from here. In the sense, all the data that we'll get right now from scraping all those URLs, we want to structure it like this. And to be able to do that, we have to have a variable that we return from this function, right? The variable that we'll return from this function will be called results. And it's and right now, like to begin with, when we're initializing it or creating an instance of it or initializing it right now, it has to be empty. It has to be a slice which is currently empty, right? There's nothing in it for now. And that's how we'll fill it up because it's empty in the beginning. Now you start a go routine, go func. And for when n is greater than 0, you basically start with a list of all the URLs and then you have to just go over them one by one till it becomes 0. And you're getting access to the list from this channel. Okay. Now the reason we use channels and routines and all of that is because you don't want this to happen linearly. You don't want the URLs to be scraped linearly because as in there's this list of URLs that are being passed here, and all of those URLs indicate a page, right? Because you click on a URL, you go to a page, and all of these pages, there could be hundreds of pages, right? On because his website is quite big, quicksprout.com. It's quite a big website. It'll have hundreds of links, and hundreds of these pages need to be scraped simultaneously. Like need to be scraped, period, right? But you can't wait for like let's say if you were using JavaScript or some stupid language like that, right? We would have had to wait for like you can't just do all of those concurrently. You can't just do all of this together simultaneously, right? With JavaScript, you would have to wait for one page to get scraped, then you have to scrape the other page. But with Golang, you can scrape all of them together at the same time, and this is why we use channels and go routines and all of that, because we are basically creating a channel where all of the scraping can happen simultaneously. Now, I use a lot of JavaScript. I use a lot of Node.js in my own products, and I call it stupid because I've had a lot of problems with it. I have problems debugging JavaScript a lot, but I still learn. I'm pretty good at JavaScript. I will be teaching JavaScript for some tutorials like React, because that's the best. That's basically the best front end framework, right? React and Next.js and Redux and hooks and all of that is the best for front end. But for back end, even though I use a lot of Node.js, I somehow like Golang a lot more because there's so much concurrency and its debugging is so much easier, right? Anyhow, so what you want to do is you want to range over all the URLs, the list that you just got, and if the URL is not empty, that's when you want to do something, right? If it's empty, then you don't want to do anything. If it's not empty, then you want to increment n, and you'll have a go func. Channel struct. And so what's happening right now is you have the URL, like every single URL is coming to this coroutine, and it's going to request every single like data from that every single URL. So it's going to say requesting that URL, and you will say %s. Because we want to know, like as somebody who's going to run this program, we want to know which URL. Sometimes we want to know which URL took too much time, because if there's a really big page with a lot of images and a lot of videos, and Golang is not able to come back, like that process is not able to come back from that page, that means that page is really big. We can avoid it later on, right? So, so that's the best part with Golang, that all of these processes happening simultaneously, concurrently, and you don't, one Go routine doesn't have to wait for another Go routine to finish, right? So they can all happen independently. Otherwise, if one page was really big, the complete program would have stopped just to wait for that one page to get scraped. I hope that's making sense. And I'm going to capture something in this variable called result, and that's basically going to be my scrape page. So you get each of these URLs, and all that this routine is doing is calling this function called scrape page, which is this function, right? It scrapes every single page. So scrape page, and you say tokens and the parser. And you can also check for errors here itself. So if error is not equal to nil, you'll say log.printf and countered error on which URL. So you can also say on this URL I encountered error. That does not affect our entire program, right? So only in that URL you have an error. So imagine how amazing that is, right? Your entire program does not have to stop because you found an error in one particular page. And this is why Google uses Golang as the primary language these days. I don't know if you know what's happening inside Google these days, but from what I know, from what I've heard, from all the people that I know, they use Golang very heavily in scraping and crawling all these different websites. Earlier, they used to use a lot of Python, but now they've started using more and more of Golang. It's very, very resource efficient language, right? You get so much concurrency. Then at the end, you're sending this to the work list. And that's it. So you pass all the URLs here, the complete list of URLs, and you take all the URLs one by one. One by one, you'll take the URL in this Go function. All of this happening simultaneously. Remember that in different Go routines. All of that pushing everything into one single Go channel, and all of the Go routines are calling this function scrape page, and you're getting the data from every single of those pages. So I'll just repeat again. You have a sitemap. Sitemap has hundreds of links, URLs of the entire website. That's what is the sitemap. We want to go across all the URLs. We want to take that list. So we'll go across all the URLs here, right? And you want to take that URL list, and you're going to pass that URL list here, and that results to the scrape URLs function, which is basically going to create multiple routines with one single channel called Worklist, and all of the routines are basically going to call this function called scrape page. Scrape page function just takes whatever data it finds on that website, on that page, that single page, and basically gives us a structured data in terms of the struct that we have defined. And that's the complete flow till now. That's what's happening till now. Okay. So I hope that makes sense. And that's all that I want to cover in this video, at least. In the next video, we can start working on our crawl page function, which I don't think there's much to be done there anyway. Hey guys, welcome to the 7th video of the Sitemap crawler project series. In this video, I'll just copy and paste a couple of user agents. So we had a few user agents, but we'll add just a few more. So now you have a couple more user agents. Awesome. And I'll post this project on GitHub soon, and you can just copy and paste this. I mean, you don't have to really type these on your own, right? You can just copy and paste these from my GitHub project. Now, I recommend that even when you get access to the GitHub project, don't just copy and paste this code somewhere in your program and just get away with it. I mean, watch these videos, build this along with me if you want to really understand how all this works, and only then start using this code in your other programs. Okay, don't try to rush, because if your foundations are not strong, you'll get into trouble. So the only function that we're left with now, I think, is the crawl page function. So in the last video, you saw that we were having a scrape URL function, and every single of those Go routines were going to basically calling a scrape page function, which is this scrape page function. Now, for the scrape page to happen, as in for that every single page to get scraped, for that to happen, you need to first crawl and make request to that URL, right? And once you get the data back, that's when you basically arrange that data into SEO data, and that's where you use get SEO data. Okay, but first you need to crawl that page. You need to make a request to that page, and you need to crawl that page. So to be able to do that, what you're going to do is so yeah, one thing that I think is remaining here somewhere is that crawl page needs to take two things, right? So when you are in your scrape URLs page and then you are in your scrape page, so the crawl page takes the URL as well as the token, takes two things. Okay, so make that small change there. And for your crawl page function, what you'll do is you'll say that it takes a URL, which is string, takes tokens, which is general struct, and returns HTTP dot response and error. Or error, I meant. So here you'll say tokens struct, and what's basically happening here is that for every single of those URLs, you're basically making a request. That's all you're doing. And how do you make a request? You make a request using the make request function that we have already created somewhere here. Make request has to be there. Yeah, this one, which basically creates a get request. That's all it does, nothing else. And it uses a random user agent, which we have just created, the entire list of user agents. It uses that to make lists simultaneously to not hit into the network request, so that Google doesn't think that all the requests are coming from one place. Google or any other website, right? So you're in crawl page, and what you get back from this function, you want to capture that in a variable called response, or this function could return an error, so that's what we also want to capture there. Okay. Now you want to check for the error. So if error is not equal to nil, you want to say return nil error, and you want to return, if everything goes well, you want to return the response of the error. Okay, so this was it. Actually, this was the entire function. That's all we have to do. Now I'm pretty sure that I must have missed a few things here and there, so what I'll do is I'll just go over the entire code quickly, and I'll help you in case you have made those mistakes with me. I'll help you figure out those mistakes, and then we'll run the program, and then we'll find many more mistakes and we'll fix them together. Okay. A couple of small issues that I found was that in some places I've written Worklist with W capital. That's going to lead to some issues, right? So just for being consistent, W needs to be small everywhere for Worklist. And let me just search if I have the Worklist with W capital anymore. It's not there. Okay, so perfect. The other issue that I found was that scrape URL is the wrong function. It should have been scrape URLs, like capital, right, with small s after that. So I'll make sure it's like that. It's scrape URLs. And for the extract sitemap URLs function, there needs to be one more bracket that's closed, because we have a bracket open for gofunc, bracket open for this for loop out here, and for this for loop and for the main function. So we need to have one more bracket, needs to be closed out here. In the scrape URLs function, the most important thing we have left out by mistake, which is returning the results that we created, the results that needs to be returned from this function, which is SEO data slice, right? needs to be returned. One more small issue is that this variable name had to be LOC, not LOCA, in the extract URLs function. And your scrape page function needs to have taken, let me show you, it needs to accept tokens as well. So let's go back to our scrape page function and accept the token. So here we'll say token, small token, join struct, parser. Now there are three things that I want you to do quickly. One is that in the sitemap function, there had to be an if here, right? Because if found sitemap is double equal to true, then you'll do this. And in the extract sitemap URL function, for gofunc, it's actually a function, and then this is the function definition out here. And you can go to your terminal also and run go mod tidy command, because we already have a go mod file. So just go ahead and run the go mod tidy command, because then you will get access to this package, go query package. And just do these three things quickly, and I'll show you a couple of more issues that I've found. Sorry, here at the end you'll have to add those brackets. Yeah, so actually I want to show you the issue I found here, that the parser needs to have capital P. I'll tell you why, because in scrape URLs you're defining that parser is the variable that you're passing, but parser is the struct. So that's why you need the parser to have capital P. And here this SEO data is the same as this SEO data, right? So there has to be capital S here. There are still a couple of inconsistencies. So one is this doc that we've been using till now, is doc with a small doc. That's what we want out here as well. And here the bracket needs to close here, not here. And then what I found with this extract sitemap URLs function is not the same as the one that we've defined. So what we'll do is extract sitemap, right? Whereas the one that we have defined is with capital M. Makes sense? So what you want to do is you want to just copy this name, just copy this, and you want to paste it there, out here. So that's the same function. Makes sense? Similarly with scrape sitemap function, right? There is a scrape sitemap function somewhere and it's not been defined properly. So let me find it. Scrape sitemap. Yeah, so this function, the M had to be capital because we're calling this function. Awesome. So one thing that I just missed was this find needs to have a capital F and small ind. And in the extract URLs function, you have to find the extract URLs function. Yeah, here it's not HTTPS, it's HTTP, because that's the package that you've imported on top here, HTTP package, right? That's the one that we're using. So now, so I've gone through the code and these are all the issues that I found. So now what we'll do is we'll try running the code. So after fixing all those issues, I found a couple more and I fixed all of them, and I will be leaving the link to this project, the GitHub link to this project in the description, so that you can just compare and fix those quickly. And what we'll be doing now, the main thing is that I want to show you how the program will work. So what you'll do is you'll say go run main.go. And it takes quite a while because remember the Quicksprout website has all of these different sitemaps, or all of these different links listed on their sitemap. And now you can see it's requesting every single of those URLs, which are every single page that exists on the Quicksprout website. And imagine all these hundreds and hundreds of pages. We found all those links, and then we found hundreds of those pages. Then now we're scraping all of those pages, right? So that's what's happening. It will take a while. A few of the pages might even return errors. It might have errors scraping those pages, and that's totally fine. It doesn't completely break our program because it's all happening concurrently. So some of the even if some of the pages say there's an error, all the others will return the perfect result that we want. So now I'm just going to sit and wait, and what I can do is I can probably switch off the video, and then I can turn it back on when my program is done processing. So here you can see the request has completed, and you're getting all of these different pages. This is the actual content on those pages. You can see that, right? The meta description of the URL of those pages and the request, which was 200. So based on the SEO data struct that we defined, we got all of this result back, right? So as you can see, first it scraped all the URLs. Let me show you one by one. It scraped all of the URLs on the sitemap page after checking if it is a sitemap indeed. Then it checked, started requesting all of these different links that it found on the sitemap, and then after it was done requesting all of this content, it started actually posting or showing us the actual content, which is this. So all these three stages need to be complete in your terminal before you can actually think that the project is complete. So this was a very nice and a very important project, because you can use this code in a lot of different scenarios. If you have any issues, do let me know in the comments below. I'm going to be leaving the link to the project in the description box below, and I think once you've gone through along with me for the entire project, you shouldn't have any issues, I think. But in case you have any issues, put it in the comments below. I'll help you out. Thank you for watching. Do subscribe if you haven't subscribed already to this channel, because you'll keep coming to witness such awesome content. So thank you for watching, and I'll see you in the next some other series.
It's not a game, it's a rich